In this video, we're going to look at section 1.3 on linear functions. We'll really be reviewing this because you've seen linear functions before. When we talk about lines, the first thing we talk about is the slope of the line, and we call that m. The slope is m. And if you have 2 points, when you define your first point as being x sub 1, y sub 1, and your second point as being x sub 2, y sub 2, the slope is defined by taking y sub 2 minus y sub 1, so the y-coordinate subtracting the y-coordinate, and then in your denominator you take x sub 2 minus x sub 1, where those two are not equivalent because the denominator would equal 0. This is also known as rise over run. The reason it's known as rise over run is because if you're subtracting your y's, your y-coordinates go up and down. So subtracting your y's will give you the difference that you're rising. Your x-coordinates in the denominator are horizontal. So subtracting those will give you the difference that you're running, if you will. So that's why it's rise over run. If we perform this calculation here, we take, in example 2, it says find the slope of the line that passes through the point 2, 1, and 4, 2. Plot the points on the first graph below and sketch the line. So first, let's find our slope. In our numerator, we take y sub 2 minus y sub 1. So that would be 2 minus 1, because the second coordinates are your y-coordinates. Then you take your x-coordinates and subtract them and get 4 minus 2. So 2 minus 1 is 1, 4 minus 2 is 2. My slope is 1/2. If we plot the point 2, 1, we go to the right 2 and up 1. There's your point 2, 1. And your point 4, 2, we go to the right 4 and up 2 is here. So graphing that line, we get this line, which rises 1. There's your rise from point to point, and it runs 2. So there's your horizontal run of 2. Let's look at slopes of lines. Now, as we had up here, we had a positive slope 1/2, and it did go up from left to right. So when m is positive, the line slants upward from left to right. When m is negative, it slants downward. If m equals 0, then the line is horizontal. And if you find your slope and you find that when you do the subtraction, you have a 0 in the denominator, that is called undefined, and you have a vertical line. So let's look at example 2, where it wants us to calculate the slopes for these lines. Go ahead, pause the video, and let's do these together. Then we'll do them together. The trick on this one is when we look at our blue line here from C to D, and we do -3 minus a -6, make sure you put those two negatives in there because you're subtracting a -6. When you have two negatives, that makes a plus. So what we really have is a -3 plus 6, which is a +3, over 5 minus 7, which is a -2, making our slope a -3/2. Our pink line here from A to B, if we subtract our y's, we have a -4 minus a -8. Again, those two negatives make it plus. So a -4 plus 8 is a +4 over -2, which gives our slope a -2. Now you can see here both of the blue line and the pink line do have the appearance of a negative slope because they're going down from left to right. Now on example 3, it says the slope of the line that passes through the point 2, 5 is 3. Graph the line. So let's find the point 2, 5, 2, 5, and the slope is 3. Well, it's nice when you write a slope to write it in the form of a fraction. So that would be 3 over 1, which means we rise 3 and we run 1. So from here, if I go up 3, kind of off the graph here, and over 1, that's going to give me a positive slope because I'm rising from left to right. I'd get the same slope if, another way to write this would be a -3 over a -1, because both two negatives makes a +3. So that would mean going down 3 and to the left 1. So either way, that is a positive 3 slope. And the line would look like that. The second part that we look at when we look at a line is, well, we look at the equation of a line. So very commonly when we look at a line, we're going to use the slope-intercept form of a line, which is y equals mx plus b, where m, as we know, is the slope, and b here is the y-intercept of the graph of the equation. So for these three lines, we're going to identify the slope and the y-intercept. So the slope, m, is always the number in front of x. So here, my slope is 3. And my y-intercept is the constant number that's out by itself. So 0, -5 is the y-intercept. That's how we write it. Go ahead and finish these next two. Let's see what you get. So on B, we get our slope is a -2, and our y-intercept is 3. So we write that as 0, 3. And on C, it's not written, but this y equals -x is the same as y equals a -1x plus 0. So our slope is the -1, and our y-intercept is 0, 0. Let's go on to some more examples and graph some lines. In problem number 6, it wants us to express the following equations in slope-intercept form, and then graph below. So to express it in slope-intercept form, y equals mx plus b, we need to solve for y. So remembering our algebra steps here, if I take 3x plus 5y equals 6, the way to solve for y is first to isolate my y term. I want to get the 5y by itself, so we are going to subtract that 3x. That will leave me with 5y equals 6 minus 3x. We're almost there. Now, to solve for y, to isolate the y, since the 5 is being multiplied by that y, we'll divide by 5. And we'll get y equals 6. We're going to split this up into two fractions. 6/5 minus 3/5 x. Now, we could have just as easily switched these order and written it as y equals a -3/5 x plus 6/5. We're a little bit more used to having the mx be first and the b be second. So in this case, that makes our slope a -3/5 and our y-intercept 0, 6/5. Now 6/5 is the same as 1.2. So my y-intercept is where we start. 1.2 would be up here. 0, 1.2 would be, I made a really fat point to cover up any mistakes, but it'd be in the lower half between 1 and 2. And then from there, we have a negative slope. So a negative slope means our line is going to go down from left to right. So if I go down 3, 1, 2, 3, and then over 5, 1, 2, 3, 4, 5, I'm going to wind up here. And then I'll graph that line from those 2 points. So our line should look something like that. Now we're going to do the same thing in part B. I'm going to ask you guys to go ahead and pause the video and solve for y here. Let's see if we get that same function to graph it. When you solved for y, you should have gotten m is 3/2 and the y-intercept is 0, -2. Please review those steps if that's not what you got. Now, whenever you do graph these, you always start with the y-axis intercept. You always start with a y-intercept. So here, we will start at the point 0, -2. That would be here. Now, our slope here is 3/2. That's fine. That's a positive 3/2. So we're going to rise 3, and then we're going to go left and right, or run 2. So rising 3 would put us up here at 1. Running 2, we want to have a positive slope here. So we're going to run 2 to the right. So we can rise 3, run 2. We can do that a couple times to get a good idea of what our line looks like. And then graphing our line should look something like that. All right. Hopefully that's a nice review of the lines for you. And in our next video, we will look at exponentials. Thanks for watching.